Hello students, we continue our previous lecture and discuss some more problem based on solution of system of simultaneous linear equation. So here we have one more problem. We have to check the consistency of given system of equation and find solution if it exists. So system of equation is 4x minus 2y plus 6z is equals to 8, x plus y minus 3z is equals to minus 1, and 15x minus 3y plus 9z is equals to 21. There are three number of variable x, y and z, and there are three equations. So we have to find the value of x, y, z. If they are distinct value, it means they might be unique or they might be infinite if solution exists, or if solution doesn't exist, system will be inconsistent. So first we rewrite it in matrix form, and the coefficient matrix is this one and this is right hand part. Now we combine coefficient matrix and right hand part, so we get augmented matrix, and now we try to find the rank of this augmented matrix. For that, first we try to convert it into simple form. For that we replace first row with r1 by 2 and third row with r3 by 3. Now we interchange second row and first row. So we get this equation. There is no need to apply this transformation. We direct implement elementary transformation from here, but we apply these elementary transformation to convert this system of this matrix into a simplified form. Now it is easy to calculation, otherwise it's little bit complicated. So now here we use elementary transformation to convert this 2 and 5 into 0. We replace the second row with r2 minus 2r1 and third row with r3 minus 5 times r1. So we get this elementary transformation. Again here, now we replace second row with r2 replace with minus 1 by 3 r2, and replace third row with minus 1 by 6 r3. Hence we get this resultant matrix. Now we will convert this one into 0. So for that we will replace third row with r3 minus r2, hence we get this resultant matrix. Here the rank of coefficient matrix is 2 and rank of coefficient matrix is also 2. So rank of coefficient matrix is equals to rank of augmented matrix. It means system is consistent. And rank is what? 2. Which is less than number of variable. Number of variables are 3. So if rank is less than number of variable, it means solution will be infinite number of solution will exist. And there are these infinite number of solutions. These infinite solution will be dependent. And out of these dependent infinite number of solution, only n minus r solution, that is n minus r is what? 1. A single solution is independent solution. Rest of all can be developed from that independent solution or generated through that independent solution. So to find that solution, we construct system of equation from this reduced echelon form matrix. So we get x plus y minus 3z is equals to minus 1, and from second equation we get y minus 3z is equals to minus 2. So let's take z is equals to k from here. So we get y is equals to minus 2 plus 3z, and x, so now putting the value of y and z in this equation, we get x is equals to 1. So the solution vector will be 1, 3k minus 2 and k. Now for different values of k we get different solution which are dependent. So if we put k is equals to 1, we get 1, 3 minus 2 is 1 and 1. So the single solution can be treated as independent solution. Now further we put different values of k. These are dependent solution and can be generated through previous one. We have one more problem. For what values of lambda and mu does the system of this given system of equation has no solution or unique solution or infinite number of solutions? So in this system of equation we are to find the condition for what the relation of lambda and mu this system has unique solution or no solution or infinite number of solutions. For that, first we write this system of equation into matrix form. This is matrix representation of given system of equation. This is coefficient matrix and this is right hand part. Now we combine A and this right hand part and we get augmented matrix. Now from this augmented matrix we try to find its rank by reducing it into echelon form. So using elementary transformation we convert into echelon form and finally reduced echelon form is this one. So now we will discuss one by one case. First we discuss in what condition solution will be unique. So we know solution will be unique if the rank of coefficient matrix is equals to rank of augmented matrix and that rank should equals to number of variable. Here number of variables are 3. So the rank of coefficient matrix and rank of augmented matrix both are should be equals to 3. So the rank of coefficient matrix is 3 possible if lambda is not equals to 5. So rank of the condition based on lambda is what? For unique solution lambda should not equals to 5. And now for the rank of coefficient matrix augmented matrix which is also 3, the condition based on these two. If lambda is not equals to 5, there is no the condition not based on whatever the value of mu. If mu is 9, it makes no difference. The rank of augmented matrix will remain 3, or if mu is not equals to 9, in that case also the rank of augmented matrix will be 3. So condition depends only on lambda, which affects or which decide the rank of coefficient matrix as well as the rank of augmented matrix. So in case of unique solution, whatever value of mu is acceptable but lambda is not equals to 5. In that case rank of A or rank of augmented matrix both will be 3 and unique solution will exist. Now for no solution, in case of no solution, rank of A and rank of augmented matrix both are different. What should be different? So and rank of A is, if rank of A is 2 and rank of augmented matrix is 3, in that case system is inconsistent. For that lambda should equals to 5 but mu should not equals to 9. In that case the rank of coefficient matrix and rank of augmented matrix will be distinct. So for existence of no solution, lambda should equals to 5 whereas mu should not equals to 9. Now third case, infinite number of solution will be exist if rank of A and rank of augmented matrix both are equal but strictly less than number of variable, which is 3. It means rank of coefficient matrix and rank of augmented matrix should less than 3. It might be 2 or it might be 1. So from here we are to reduce the rank of this system, this matrix. For that lambda should equals to 5 and mu should equals to 9. In that case the third row becomes 0 and rank will be reduced by 1. Now the rank of this matrix will be 2. Rank of augmented matrix is again 2. It means system is consistent and rank is less than 3, which is number of variable. That's why infinite number of solution will be exist. So under these conditions the system will be unique or might be infinite number of solution it carries, or it carries no solution under these conditions. Let's have one more problem. Now, for what values of k, sorry, so for what values of k, the equation x plus y plus z is equals to 1, 2x plus y plus 4z is equals to k, and 4x plus y plus 10z is equals to k square have a solution, and solve the completely for each case. Now first write it into matrix representation and write augmented matrix. Augmented matrix for the given system of equation is row wise 1 1 1 1 2 1 4 k 4 1 10 k square. Now I will convert it into echelon form using elementary transformation. So first we use R3 replace with R3 minus 4R1 and R2 replace with R2 minus 2R1. So we get this matrix. Now we'll try to convert this minus 3 into 0. So we use second row. So and elementary transformation will be R3 replace with R3 minus 3R2. In that case, this place will become 0, and we get this resultant echelon form. Or we can say when we simplify this term, it can be written in this form. Here, the third row will decide solution will be consistent or inconsistent. Here, if we go through the rank of coefficient matrix, this is coefficient matrix, and this will decide the rank of coefficient matrix. From here, the rank of coefficient matrix is 2, and this whole matrix will decide rank of augmented matrix. From here, if this term is 0, if this term, which is k square minus 3k plus 2, if this term is 0, this third row will completely 0, and the rank of augmented matrix and rank of coefficient matrix will be 2, means same. In that case, system will be consistent. But if this k square minus 3k plus 2 is not equals to 0, then rank of augmented matrix will be 3, whereas rank of coefficient matrix is 2. It means the rank of both matrices is distinct. So solution system is inconsistent and solution doesn't exist. So if k square minus 3k plus 2 is not equals to 0, it gives us either k minus 1 into k minus 2 is not equals to 0. In that case, solution will not exist. It means we get for k not equals to 1 and k not equals to 2, solution will always system will always inconsistent, solution never exists. But in the case either k is equals to 1 or k is equals to 2, system might have some solution. But for all other values other than 1 and 2 of k, system is always inconsistent. So this is the condition of inconsistency when k is not equals to 1 and k is not equals to 2, system remain inconsistent. Now for consistency, this term should equals to 0. It means k square minus 3k plus 2 is equals to 0. It gives us either k is equals to 1 or k is equals to 2. So for k is equals to 1, system will remain consistent, and for k is equals to 2, system will also remain consistent, but have different solution in both cases. And in the case of consistency, the rank of matrix is 2, which is less than number of variable. It means if this system is consistent, the given system of equation, the system is consistent, it contains infinite number of solution. So first we check the condition when k is equals to 1. If k is equals to 1, given system can be reduced into x plus y plus z is equals to 1 and minus y plus 2z is equals to minus 1. From here, the system has 3 number of variable and equations are 2, so one variable will be independent, so we take z is equals to a. Here a is arbitrary constant. So from here we can obtain the value of y, which is 2a plus 1. Now putting the value of y and z into this equation, we get x is equals to minus 3a. So in case of k is equals to 1, system has solution in the form small x equals to minus 3a, y is equals to 2a plus 1, and z is equals to a. Now for other case, if k is equals to 2, in that case given system reduced into this form, x plus y plus z is equals to 1 and y minus y plus 2z is equals to 0. From here we obtain y is equals to 2z, and now putting the taking z is equals to b, we get y is equals to 2b, which leads x is equals to 1 minus 3b. So in case of k is equals to 2, the solution vector will be 1 minus 3b, 2b and b. So, and for different values of b, system has different solutions, which are infinite number of solutions and dependent. So in this way we are to solve the system of simultaneous linear equation. Thank you.